Okay, so here we're going to look at a thing called the discriminant, which is a way of telling how many solutions a quadratic equation has. So here I have three graphs of quadratic equations, where I just made y equal the ax squared plus bx plus c. And you notice with the red one, it only has one x-intercept right here. So that means that negative 2 is the only solution of 0 equals x squared plus 4x plus 4. So yeah, that's the only value of x that makes the y coordinates come out to be 0. With the green one here, I can see that if I wanted to solve this equation here, 0 equals x squared minus 2x plus 4, there are no values of x that make the y equal to 0 here, so this has no real solution. But, there might be complex number or imaginary number solutions. And with the blue one here, there's these two values here that look like those are values of x that make y 0. Those two values of x are something like approximately 1.6 and 4.4, something like that. So this has two solutions. So what we're going to see is what is it about the values of a, b, and c with these different ones that you can use to predict how that will happen. And so we could just plug these into the quadratic formula to see how it will go. And I'm not going to make you sit through all of it, but I'll go through the steps for solving this equation with the quadratic formula. So the a is 1, b is 4, c is also 4. So the solutions will come out like this. And we'll notice what happens here when you do 4 squared, that's 16, and then minus 4 times 1 times 4 is also 16. That will give you a 0 inside that square root. And so the solutions are negative 4 plus 0, the square root of 0 is just 0, and negative 4 minus 0 they're both the same thing. So because it's only plus 0 and minus 0 do the same thing. So you really just get x equals negative 4 over 2, also known as negative 2. So it's only one solution. And the reason that came out to be only one solution is because of this fact here, that this was 0. Okay, now what about the other ones? Let's go over here with the green one and see how we can tell that this will have no real solutions when we try to solve this. I'm going to plug this into the quadratic formula here, which will look like this. So negative 2 just becomes 2. The interesting thing is what happens inside the square root here. The negative 2 squared becomes positive 4, and then you have that minus 4 times 1 times 4 is minus 16. So you end up with a negative number inside here. And whenever you have a negative number inside a square root, it doesn't give you a real number result, which is why you don't see any solutions on the real line, which is the x-axis here, but it does have a complex solution. And in general, hopefully what you can see is that you're going to have two complex number solutions and no real number solutions when the thing inside the square root is negative. And how about the blue one here? Well, let's plug your a, b, and c into the quadratic formula. And with this one, when you do the negative 12 squared, you get 144. Minus 4 times 2 times 14 ends up being 112. When you subtract that, you get 32 inside the square root here, which is a positive number. So when you do 12 plus or minus that, it's going to give you two different real numbers. So this thing inside the square root is what we call the discriminant, and it helps you figure out how many solutions an equation has. So here it is copied from the book. The the discriminant is b squared minus 4ac, and these are the three situations I just described. Either it's positive, or it's 0, or it's negative. And because that's the part that's inside the square root of the quadratic formula. And here's an exercise we can do. I'm going to do A for you just because I haven't done anything quite like this yet. And I'll let you do B on your own. So we're going to see, we want to know how many values of x make it so y is 0. And we're talking about the x-intercept. So we can say our A here is 1, B is 5, and C is 7. Plug those into the discriminant formula so we don't have to do the whole quadratic formula. And see, we're going to get D equals 5 squared minus 4 times 1 times 7. And that will come out to be 25 minus 28, which is negative 3. So that means this has no x-intercepts. Because if you were going to solve this equation with a 0 here equals all of this stuff, then with using the quadratic formula, you would end up with the square root of negative 3, which gives you complex solutions but no real solutions. I'll let you do B here on your own. And in the next video, I'll do one more tricky kind of problem.